Because data buses are used to carry information in and out of a CPU, the more data buses available, the better the CPU. If one thinks of data buses as highway lanes, it's clear that more lanes provide a better pathway between the CPU and its external devices, such as printers, RAM, and other devices. By the same token, that increase in the number of lanes increases the cost of construction. More data buses mean more expensive CPUs and computers. The average size of data buses in CPUs varies from 8 to 64. Early personal computers, such as the Apple II, used an 8-bit data bus, while supercomputers such as the Cray use a 64-bit bus. Data buses are bidirectional because the CPU must use them to either receive or to send data. The processing power of a computer is related to the size of its buses because an 8-bit bus can send out 1 byte at a time, but a 16-bit bus can send out 2 bytes at a time, which is twice as fast. Because the address bus is used to identify the devices and memory connected to the CPU, the more address buses available, the larger the number of devices can be addressed. So in other words, the number of address buses for a CPU determines the number of locations with which it can communicate. The number of locations is always 2 to the x, where x is the number of address lines regardless of the size of the data bus. For example, a CPU with 16 address lines can provide a total of 65,536, or 2 to the 16th, or 64K of addressable memory. Each location can have a maximum of 1 byte of data. This is because all general purpose microprocessor CPUs are what are called byte addressable. Another example, the IBM PC AT uses a CPU with 24 address lines and 16 data lines. Thus, the total accessible memory is 16 megabytes. That's 2 to the 24th megabytes. In this example, where would 2 to the 24th locations be? And because of each location is 1 byte, there would be 16 megabytes of memory. The address bus is considered to be unidirectional, which means that the CPU uses the address bus only to send out addresses. The total number of memory locations addressable by a given CPU is always equal to 2 to the x, where x is the number of address bits regardless of the size of the data bus.